given that 4 plus 5i is a complex root of this polynomial, find all remaining roots. So the first thing is that if 4 plus 5i is a complex root, then by the conjugate root theorem, 4 minus 5i is also a root. So we've already found the second root, and because it's a cubic, we know there are 3 roots in total. We found 2 of them already. Now we need to find the third one, which we know has to be real. It has to be real because conjugate complex roots come in pairs because of the conjugate root theorem. And because we can't have another pair, there's only one root left, it has to be real. So now we're going to find that last root. There's a few ways we could do it. The first way would be to do polynomial division. So what this means is that f of x is equal to x minus 4 plus 5i times x minus 4 minus 5i times x minus some other value that we don't know, x minus b, let's call it. And we're trying to find that value of b. Essentially, we can expand this and equate it with this version of the polynomial and see what value of b we need. So expanding this, we get x times x is x squared. Then we're going to get minus 4 plus 5i x. We do that one times that one. We're going to get minus 4 minus 5i x. And we're going to get 4 plus 5i times 4 minus 5i. And all of that's being multiplied by x minus b. Simplifying, we've got minus 4x, so that's minus 8x. And then we've got minus 5i plus 5ix, so they cancel out. We've got no ix's. And then here, 4 plus 5i times 4 minus 5i, this is a difference of 2 squares. So 4 times 4 is 16. And then 5i times minus 5i is going to be minus 25i squared. But that's going to simplify down to I squared is negative 1. So it's x squared minus 8x plus 41, because this becomes plus 25, times x minus b. So what does b have to be? Well, we know that when we expand this, we're going to get 82. So that means that we've got to have x squared minus 8x plus 41 times by x plus 2 to get that 82. That means the third root is minus 2. So we found our 3 roots, 4 plus 5i, 4 minus 5i, and negative 2. We could have approached this in slightly different ways. We could have done polynomial division. Once we work this out, we could have done the cubic divided by this to work out that linear factor. We could also probably have used the factor theorem. Given that we have to find one more at this point, we could just start substituting values into f of x and see which one comes out. We'd probably get to minus 2 fairly quickly. It's a good option if that root's going to be small, but if that root was something like 17, that wouldn't get us there. So that's a possibility, but it might fail us if we don't get it within the first few numbers. This is a more guaranteed way to get there.